Today in this video we will be discussing about bridge rectifier, its working and advantages and where it can be used about its application. Before going too deep into our topic, just we will brush up our rectifier concept. So what made the rectifier the most important thing is that few electronics devices use the DC as their input current for processing. So the alternating current should be from the grid distribution should be converted into the DC in order to required by microchips, batteries and industrial motors, etc. So in order to do so, we are going for rectifiers. So in rectifiers, the unidirectional conduction property of PN junction diodes holds the main key and the main important component of that rectifier circuit. Coming into our topic, bridge rectifier, this is the circuit diagram of the bridge rectifier. In case of full wave, the performance and all was good compared to half wave, but we will be using center tap transformer in full wave, which makes the device very bulk and it costly. So in order to overcome that particular issue, we are going for the bridge rectifier. In bridge rectifier, we are using the standard transformers, and then we are using 4 diodes which is being arranged in the Wheatstone topology, and then we are having the load resistance RL and the capacitor. The main purpose of capacitor we already discussed. It is used for filtering purpose. It makes the output smooth by reducing the noises, etc. So coming to the working of the bridge rectifier, when the positive cycle of AC is being given as the input to the transformer, the diode D1 and D4 is being forward biased and the output is being flowed through host circuit, and the output is being measured in the RL resistor. So here D3 and D2 will not be connecting, it will be reversed bias. So in negative part of AC, so current is being given. The D3 and D2 will be in conducting phase, and D1 and D4 will be in non-conducting phase. So D3 and D2 will be forward biased, and the particular current can be measured in the RL. So coming to the output characteristics, if you see, first one is the AC input which will be applying to our transformer, which has a peak voltage of Vm and with a zero mean. Coming to the next diagram, it is an pulsating DC unfiltered output. So the yellow color represents the output from the D1 and D4, and their blue color represents the output from the D3 and D2. So the output is being passed to the capacitor in order to smoothen the output and remove the unwanted noise, we are getting approximately the filtered DC output, which is very much close to our normal DC output. Coming to the parameters, the output voltage can be measured by using the value dVdc, which is twice the amount of the peak voltage divided by pi. The RMS value is somewhat equal to 0.707 Vm. The efficiency is 81.2%. It is the theoretical efficiency, which is very much equivalent to our full wave rectifier. The ripple factor is 0.483, and which is very much higher than half wave rectifier, and transform utilization factor is very high compared to the half wave and full wave rectifier, which is around 81.2%. The full secondary winding is being used continuously, which makes the utilization factors to move into a very higher end. Next comes to the advantage of the bridge rectifiers are, first foremost is transformer flexibility. It is not very expensive since we are not using the center tap winding. Next, because of not using the center tap winding, the cost is very much effective, and the size of the bridge rectifier is very small. It is a 4-pin IC package. Maximum utilization can be achieved, and because of that, transformer utilization factor is very high, and it can be used for high power scalabilities. Coming to the comparison matrix between the central tap full wave rectifier and bridge rectifiers, transformer which is used is for center tap, it is very special and heavy. In case of bridge rectifier standard, and it is very light. PIV stress is twice the peak voltage, but it is very low. It is equal to the peak voltage. And the transformer utilization factor, that is efficiency, is 69% in case of central tap. In case of bridge rectifier, it is 81.2. BCB footprint it is very large due to usage of central tap, but in case of bridge rectifier, it is ultra compact IC. The diode voltage loss is 0.7 only in case of central trap, but in case of bridge rectifier 1.4, which is considered as a one negative point over of using the bridge rectifier. So the key takeaway from our comparison matrix is that the bridge dominates on cost, size and the efficiency, and conceding only on low voltage drops and split supply capabilities. Coming to its applications, it is being used in heavy industrial applications, automobile server and backups, consumable switch mode power supplies, which is being used in every modern adapters which can be directly rectify the main voltage. Hope in this video you have understood what is meant by bridge rectifier, working of bridge rectifier, its advantages and applications. Thank you.